Welcome DKP Sogong aboard. Your learning journey starts now. Ever seen a shadow and wondered what made it? The Hodge conjecture asks something similar for shifts in higher dimensions. It's not just about spotting an algebraic shape. It's about proving that every certain kind of topological shadow must have come from one. So how do we prove this shadow to source thing? We need a blueprint. Think of it like this. First, we take our complex geometric object X. It might look infinite, but its core structure is built from a finite set of rules. Second, we identify the basic building blocks, the irreducible subvarieties of codimension P. These are our potential sources. Third, we build a memory bank, the cohomology group H2P of X, which captures all the global relationships derived from these sources. Fourth, we apply a special filter, the rational P-balance projection. This isn't just any filter. It's designed to catch only those shadows perfect balanced between holomorphic and anti-holomorphic aspects and stable under rational transformations. Finally, fifth, we show that whatever passes through this filter must originate from a finite combination of our basic sources, forming an algebraic cycle Z. It's a journey from the abstract shadow back to concrete geometric origins. Now, why does this specific filter, rational PP balance, work so well? Two key ingredients. First, rationality. When we say rational, we mean stable across different coordinate systems, conjugations, and representations. It strips away any dependence on arbitrary choices of phase or coordinates, forcing the underlying source to be fundamentally tied to the geometry of X itself. Second, PP balance. This condition ensures perfect symmetry. Think of it as requiring equal parts holomorphic and anti-holomorphic information. No leftover directional bias, no one-sided complex dependencies. What happens when you combine these two? You eliminate all possible ways a shadow could exist independently of its source. Any remaining relation must be carried by the finite algebraic structures within X. There's simply no room for a source-free ghost in the machine. And here's the payoff. The projective finite source completeness theorem basically states, if you have a global relation that's both rationally stable and perfectly balanced, PP, then it must come from a finite set of algebraic generators within your variety X. No exceptions. This directly leads to the main result for the rational Hodge conjecture. That map, CO superscript P subscript Q, taking algebraic cycles CH superscript P of X tensor Q and sending them into the rational PP, part of cohomology H superscript P of X, Q, intersect H superscript P of X is surjective. Every element in that target space is hit by some algebraic cycle. The shadow can always be lifted back to its source. This is huge because it connects the algebraic world directly to this specific topological subspace via a fundamental property of finite generation. Why does this proof strategy succeed where others struggle? It hinges on understanding source lift correctly. It's not about randomly guessing algebraic cycles and checking their shadows. Instead, it's about recognizing that the balanced rational shadow already carries the generative history embedded within the finite structure of X. Because X is finitely generated, there's no external freedom for a shadow to latch onto. Rational coefficients are crucial here too. They allow us to normalize things like multiplicities from coverings, preventing them from mimicking new sources. And importantly, this doesn't automatically solve the integral version. Integral coefficients preserve discrete torsion and other lattice effects which can block the lift, showing why the rational conjecture holds while the integral one often fails. So, wrapping up, the Hodge conjecture, specifically the rational version, is fundamentally about recovering the geometric source from its balanced topological shadow. By leveraging the finite generation of the variety, the constraints of PP balance and the stability provided by rationality, we ensure every such shadow must originate from a finite algebraic cycle. It's a beautiful interplay of structure and constraint.